Thank you very much for coming along to my talk. My name's Tim. I'm a developer attached to the Bitbucket team at the moment, but I've spent a lot of time working on our other Git-related tools, Fisheye, Crucible, SourceTree a little bit, and JIRA as well with our DVCS integration. So today we've got quite a technical presentation. We're going to be talking mostly about Git and a feature of Git called aliasing. But we will talk a little bit about how you can use aliases to interact with Bitbucket and JIRA to enhance your workflows. But does everyone here have sort of a passing familiarity with Git? Is everyone using Git? Hey, fantastic. Okay, cool. So Git, how many people have created a Git alias before? Okay, fantastic, about half the audience. So an alias in Git is basically a way to create a shortcut for a Git command. Now, there's no specific alias command in Git. Instead, you need to use the git config command, which creates a new entry in the alias section of your global Git configuration. Now, what an alias has is two parts. Basically, there's a name for your alias, which is what you're going to type in at the command line to invoke it, and then the actual command string, which is what will be passed on to the Git command when you invoke that alias. Now, when I asked before, most people in the room have created an alias before. Quite often when I'm looking at my coworkers' Git config files, they've created aliases which look a little bit like this, basically shorthand for an existing Git command. Now this is great. It means that you save a few characters every time you run commit, or we're so using CI, or running ST for status, or CO instead of checkout. But it actually turns out aliases are far more powerful than just a way to save you a few characters in your terminal. Aliases actually solve a huge problem that the Git project, as in the Git open source project, has. So Git moves incredibly quickly for an open source project. They had 5 major releases last year, and each release had over 100 bug fixes and improvements, and performance improvements. That means that it's a rapidly evolving tool. But an interesting thing about Git is it's a command line tool. The only way that you interact with it is by typing out commands in your terminal or using another tool like Bitbucket or SourceTree, which ultimately is going to invoke those same commands on your behalf. So Git also has a strong commitment to backwards compatibility, which means when you upgrade to the latest version of Git, you don't expect things to break. You expect to be able to do the same commands yesterday as you can once you do the upgrade. This is fantastic for tool vendors like Atlassian because it means our customers can upgrade the version of Bitbucket or SourceTree that they're using, or upgrade the version of Git independently, and it will continue to work. There's a bit of a paradox there. How can you have rigid backwards compatibility and still ship 100 new changes every couple of months to your customers when your interface is a command line? Well, it turns out there's a few different options. You can create a new Git command, and in fact, these are a bunch of the over 400 commands that ship with the stock Git implementation. You can create new options for those commands, and if you've had a look at the Git man pages recently, you realize that there are thousands of options you can use in combination with these commands to achieve different effects on your Git repository. And the third thing you can do is create new configuration parameters that control the behavior of these commands when you define them in your config properties files. So Git actually takes a bunch of different approaches to making sure that their tools are backwards compatible when they do new releases. But this means that there's an inherent complexity to using Git because they have to introduce all of these new options to introduce new behaviors. Now to illustrate this, let's look at one of Git's really cool, unique commands called Git Stash. How many of you use Git Stash on a regular basis? Oh, fantastic. Okay, only about a quarter of the room. For the rest of you, this is a pretty amazing little tool. Now, Git Stash is not to be confused with Atlassian Stash, which was the name of Bitbucket server up until a couple of years ago. Git Stash is actually a command you can use with your local Git repositories. Now, what Stash does is it squirrels away changes from your local working copy in a place that's separate to your repository, and then you can reapply those later on. So for example, imagine I'm working on a new feature. So I've made some changes to a file in my working copy called work.txt, and then someone runs up to me and says, "Hey Tim, our production servers are on fire. Can you try reproducing this issue locally?" Now I've made some changes to my repository, but I'm not quite ready to commit. So I can run the Git Stash command, and it will take my changes from work.txt and store it in my stash. Then I can go and reproduce that problem in production, and when I'm ready to go, and it's basically given me a fresh working copy. So it's as if I just checked out that branch and haven't made any changes. And then once I'm ready to continue, I can run git stash pop, and it will reapply those changes to my working copy for me. So Git Stash is a really powerful tool in your Git toolkit for switching context to work on something else. That's when it works. So Git Stash is great if you've made changes to an existing file. But for that quarter of the room who've run Git Stash before, you may have run into the situation where instead of making changes to an existing file, you've created a new file in your working copy. Now, if you run Git Stash after you've created a new file, it doesn't do anything. Now, the reason for this is that Git Stash only actually operates on tracked files. So when you create a new file, it doesn't do anything for you. And when you run git status, you still have that file sitting in a local directory. Now, most people, well, myself included up until relatively recently, will work around this by running git add to add that to their index, and then running git stash. But it actually turns out there's a better way. So when Git looks at the files and the changes in your working copy, it treats them as being in one of 4 different buckets. It can be an unstaged change to a tracked file, so basically a change you've made but you haven't run git add. Or it can be a staged change that you have added to your index. Or it can be a change to an untracked file. So basically you've created a new file that Git doesn't know about. Or it can be a change that you've made explicitly to an ignored file, which you've told Git not to think about because it's sitting in your .gitignore file. Now when you run git stash, it only considers those first 2 types of changes to tracked files. But if you look at the git stash man page, it actually turns out you can use the include untracked option to make Git Stash consider all of those other new files that you've created as well. So that's not too bad. I can remember that I need to use Git Stash usually, and if I've created a new file, I should use Git Stash include untracked. Or maybe I'll just always run include untracked because that's kind of what I'd like the default behavior to be. Now I suspect that include untracked was actually added as an additional feature on top of stash after the original stash command was introduced, which is possibly why it's a little bit backwards in terms of what you'd want the default to be. But if you read the man pages, it turns out you can also use the --all option, which will stash not just untracked files, but your ignored files as well. And this is really powerful if you've got build artifacts sitting around in your repository that you want to put in your stash too. So for example, I usually ignore build artifacts like binaries and log files, but sometimes it's useful to keep that context if I'm working on a couple of different features in parallel. So I can run git stash --all and then git stash pop, and it will actually cache all those build artifacts for me too, so I can do a proper context switch. But that's not all git stash can do. You can also run git stash keep index, and then it will only stash the unstaged changes to your files. And this can be great if you want to have fine-grained control of what goes into your stash. So we've got a few different things that we can do with the git stash command. And now this is where I start to run into a bit of a problem. Because it's not that these options are badly named, they do exactly what they say they do, but I have a really hard time remembering because they're kind of inconsistently named. So instead of trying to keep this all in my mind, I created a series of aliases that allow me to much more easily stash what I'm looking for. So basically, if I want to stash just my index, I run git stash with a slight Kiwi accent. But if I want to stash absolutely everything, I run git stash, and I know that I've got a complete working copy as if I just freshly cloned the repository. And this is a really cool use case for Git aliases, because it means you can define mnemonics for common Git operations rather than having to go back to the man pages or Googling and running the Stack Overflow every time you need to do something. So aliases not only save you time, they also allow you to encapsulate options that you use for common Git commands. But as we'll see over the next few slides, you can also use it to create some really powerful functionality on top of Git by chaining Git commands together and then actually chaining them with other tools from the Unix toolkit. And then finally, you can also share Git aliases with the rest of your team using a mechanism that I'll show you at the end of the presentation. So I've actually created a repository with all of the aliases that I'm going to be talking about, and there's a link at the end, so don't worry too much about taking photos and notes and stuff. So as I mentioned before, when you run the git config command and define a new alias, it creates a new entry in the alias section of your global git config properties file. So now we're going to look at a slightly more complicated example, which I'm calling git which. Now, git which basically lets you search for a branch that contains a particular string in your repository. So you might type git which JIRA 7 or any other issue key, and it will print out branches that contain JIRA 7. Now, the way that this works is that when you provide a parameter or an argument to a Git alias, then the Git aliasing system takes those values and appends them to the end of the command string that gets evaluated. So that JIRA 7 ends up being passed as the first argument to the grep command in this particular case. So if you want to chain aliases together like this, you have to prefix the alias command string with an exclamation mark. And this tells Git to drop into shell mode as opposed to just passing the alias string onto the Git binary itself. So this means that you can enhance your Git aliases with all sorts of other cool bits from the Unix toolkit like awk and xargs and grep. So let's take our git which alias and do something a little bit more cool with it. So let's build another alias called, which I'm calling git lucky. Now git lucky actually uses a subshell to invoke our git which alias. And what lucky does is actually search for a branch that contains that string and then check out the first branch that matches. So it's a little bit like I'm feeling lucky search on Google. So you'll see here we've got a subshell which is invoking git which, and then that output is being passed on to the git checkout command. But instead of using, instead of just appending the arguments from the alias to our command, we're using a positional argument using $1, which is just bash syntax for the first argument, and then passing that into git which. So you can use positional arguments to achieve even more power with your git aliases. However, this command as is won't work because when the alias gets evaluated, it's actually going to substitute $1 for that JIRA 7, but then it's also going to append JIRA 7 to the end of the command line. So you're going to get something that looks like git checkout JIRA 7, JIRA 7. So if you want to use positional arguments like this, then you have to actually wrap it in single quotes and then pass it off to shell to evaluate. And so this hack kind of works around the fact that those arguments are appended at the end. You don't have to remember too much about why this works. Just remember if you want to use $1, $2, etc., you should wrap it in quotes. So speaking of variables like $1, you can also use environment variables, just like any other bash script, as part of your Git aliases. So this is another alias called Standup. How many of you have a daily stand-up where you update your team on status? Okay, fantastic. So for those of you who don't, basically a stand-up meeting is you take 3 minutes in the morning to tell your team what you did yesterday, what you're going to do today, and if you have any blockers. Or, you know, the format can vary a little bit. Now, one of the things that I run into as a developer is I don't remember all of the stuff that I did the day before. So the standup alias uses git log, which basically outputs a list of commits, to show you any changes that have occurred on any branch. That's what the --all does. Committed by you, so it's using your standard $user environment variable. So this kind of relies on your operating system user being the same as your Git username. That have occurred since 9 a.m. yesterday. So basically over the last 24 hours since your previous stand-up meeting. Now, Git actually has some pretty sophisticated relative date timestamp stuff. So you can use things like yesterday and last week and last month, which is kind of neat. And then it's changing the format of that git log output to be %s, which means the subject of the commit, or the first line of the commit message. So what we get is something that looks a little bit like this. Basically just a little brief list of all of the changes we made to our code base on any branch over the last 24 hours. Now this works great, except the team that I work on is based in San Francisco, and I am based in Sydney. And since daylight savings time kicked in, I'm not necessarily online at the time that they usually do their stand-up. So I've made a little adjustment to the Git standup alias that I'm calling lazy standup. And what lazy standup does is it evaluates Git standup and then pipes the output to say, which is a speech synthesis command on OS X, because we use Mac Minis for our wallboards. So now when I run lazy standup, a disembodied voice from my team's wallboard tells the team what I'd done the day before. So I can just wire this up to a cron job, and all of a sudden I have a little sort of remote ghost doing my daily stand-ups for me. So these have been a few fun examples of the stuff you can do with aliasing. But now I want to take some of the knowledge that we've got now, so using parameters and chaining commands to do some really powerful stuff. And the first thing we're going to do is going to solve a little bit of an inherent tension that there is between the Git open source project and Git hosting providers like Bitbucket. So Git is a distributed version control system. It's very democratic. Everyone has their own copies of repositories, and they can contribute changes and share them with the rest of the team. Bitbucket, however, would like to kill the DVCS because we're trying to get you to centralize and have one canonical repository on Bitbucket that your team contributes to. And this is actually pretty good for professional teams because it means there's one place for your CI systems to connect to and one place for developers to go and get the latest changes. But there is one drawback with this cunning plan, and that is if Bitbucket is down, it becomes very hard to share code with the rest of your team. Now Bitbucket has pretty good uptime. Last quarter, actually I don't know if I got, well, not the stats for last quarter, but the quarter at the end of last year we had, let me just double check I get this right. Yes, otherwise my ops team would kill me. 99.96% availability. So Bitbucket was down for roughly 52 minutes, which means that you could not get access to your code for 52 minutes during the quarter, which sounds really good unless you want to share code during that 52 minutes. So a little known feature of Git is that it actually ships with a built-in Git server called the Git daemon. Now the daemon will actually serve your local Git repositories on your network so other developers can clone from you directly rather than having to go via a hosting provider like Bitbucket. Now daemon, just like a lot of other Git commands, has some fairly arcane options associated with it. So usually I have to Google for it and then go to Stack Overflow and then leaf through some man pages to figure out how to run the thing, which led me to create an alias called Git Serve. And that's actually a good pro tip. If you find yourself repetitively Googling for the same Git invocation, that's a really good example of a time when you should create an alias. Now Git Serve works great, and it starts serving my local repository over the Git protocol on port 9418. So this is a really handy way to share my code with developers who have access to my local port 9418, which unfortunately is nobody because my team is based in San Francisco. So I created another alias that uses another little tool called Ngrowth to be able to share my code more effectively. Does anyone here use Ngrowth? Ah, fantastic. I love telling people about this tool because it's just like Git, it is indispensable to my workflow. What Ngrowth lets you do is basically proxy a local port out onto a public port available on the internet so anyone can access that port. So if you're a web developer, you can use this to share a locally running web application with anyone in the world by sending them a URL. But it turns out that Ngrowth also supports proxying arbitrary TCP ports as well. So I created an alias called Git Ngrowth. Now what Git Ngrowth does is it forks the Git daemon process, starts Ngrowth, and starts proxying that local Git port out onto the public internet for someone else to clone. So then I can just copy this URL, send it to my teammates on HipChat, and they can clone the repository. This is hypothetical actually. I must admit Bitbucket hasn't been down when I've needed to use it. But this could be potentially useful in a scenario like that. Now the way that Git Ngrowth works is a little bit fancier than some of the other aliases we've been looking at. Basically the alias is defined as an anonymous bash function. Now this allows us to split the alias out across multiple lines. It also works around that problem of the arguments being appended to the end of the command string. And it looks a little bit nicer than having to shell out to sh. So we're spawning two new processes, Git Serve and then the Ngrowth process. But to be able to grab that URL to send to my teammates on HipChat, we actually have to figure out what that URL is because it's determined dynamically by Ngrowth when you invoke it. Now, a little cool feature of Ngrowth that I only found out recently is that when you run Ngrowth, it starts up a little local API server where you can inspect locally running tunnels. So we can hit that using curl, find the public URL, and then send that to our friends on HipChat. Now there's one other cool little tool I want to point out here called JQ, which if you spend much time on the command line, particularly as a web developer, if you're working with JSON, it's awesome. It's an awesome way of like plucking properties out of JSON files. And you can also use it to parse JSON files and change properties and then reassemble them. So if you're working with APIs and bash a lot, super, super handy little tool. Now, you might look at this slide and go, Tim, the sign on the door said Git Aliases of the gods, but it kind of looks like this is a seminar on Bash programming. And that would be a fair comment. Most of that is Bash. And in fact, a Git alias, for the most part, is Bash. Or, raw shell if you prefer. Okay. So you have a bit of a philosophical question as to when you should create a Bash alias and when you should create a Git alias. And for me, it comes down to context and namespacing. The difference between Bash aliases and Git aliases is that Git aliases can only be invoked by typing Git and hitting space. And if you've set up auto-completion with Git in your terminal, which is, if you haven't, please do, it changes your Git experience immeasurably, then it'll auto-complete on your alias names as well. So really the rule is, if you're creating a new little tool as an alias, and it doesn't use a Git command, and it doesn't touch your .git directory, then it should probably be a Bash alias. But if it does use a Git command, then consider writing a Git alias instead to get that nice auto-completion and context and namespacing. So next, well, actually, and one other cool thing that you can do with aliases, particularly in the context of a Git repository, is use them to interact with other services built on top of Git. For example, my favorite Atlassian tool, Bitbucket. Now, has anyone tried out Bitbucket pipelines yet? Oh, cool, okay, maybe 4 or 5 people. So if your team's using Bitbucket, you may have noticed we have this new little pipelines link in the left-hand side of the navigation. And if you click on that, if your team has set it up, then you'll start getting build statuses showing up for each of your commits. So Bitbucket Pipelines is a continuous integration and deployment system built into Bitbucket. So rather than having to use something like Jenkins or even Bamboo, you can actually get your builds triggered automatically inside of Bitbucket Cloud every time you do a push. And if you click through to one of those build statuses, you'll see basically a set of script steps being executed in a Docker container that is the environment for your build. Now, the way that you configure Bitbucket pipelines is by creating a special file in the root of your repository called bitbucketpipelines.yaml. It contains an image, which is the Docker image that's going to be used for your build, and then it contains a set of pipelines that define pipelines that are going to be run when you push new changes to your repository. Now, one cool feature of pipelines is you can also define custom pipelines. These aren't triggered automatically when you push, but are instead triggered manually via the UI. So this is really good if you have jobs that you don't want to run automatically, but want to be able to go and select a particular commit and then trigger a pipeline for it. So for example, deploying the application or deploying part of the application, like your documentation, or running a heavy-duty job like static analysis or security vulnerability analysis. You could have a custom pipeline that you can run occasionally for those types of things. So the way you trigger a pipeline is by clicking on the Run Pipeline link in the Bitbucket UI for a particular commit. But Bitbucket Pipelines also has a kick-ass API that lets you trigger these things programmatically, which is a pretty good use case for a Git alias. So I've created another little alias called Git Pipeline that lets you trigger a named pipeline for a particular commit. Now, when you're dealing with Git services, quite often you need to provide a commit ID or a SHA-1 hash to identify which commit you want to use. Now here we're passing a short SHA, which is the first few characters of a full commit. But sometimes you're not going to want to go and copy that short SHA. You're going to want to use something like a tag instead. So for example, if we're deploying documentation, I could run git pipeline docs and then specify the tag which I'm going to deploy. Or I might want to use something like a feature branch to run some tests or static analysis against a branch that's currently being developed. Now, Bitbucket Pipelines actually supports passing these identifiers directly to the API, but if you're working with another service that requires the fully qualified SHA, you can use a command called Git Revpass to transform these things into a SHA. So Revpass is actually a plumbing command that you don't usually invoke directly, but it will translate anything that references a commit into that actual commit ID, which can be really useful when you're defining some more complex aliases. So Revpass can translate things like short SHAs, branches, tags, and also some other cool things like reflog short names. So the Git reflog is basically a log that Git keeps automatically for every branch you have in your local repository. And it tracks what commits that branch pointed to at particular points in time. So I can use Revpass to say, hey, give me the commit that master was pointing at yesterday, or 6 months ago, or any other point in time. You can also use ancestry references as well. So you can use a tilde to say, find me the parent of this commit, or the grandparent of this commit, in this case, with tilde 2. So Revpass is super useful for building more advanced Git commands, and it actually has a sister command called Git revlist. Now revlist is a little bit like Revpass, but instead of just printing out one commit, it actually prints out a series of commits between two, a series of commits based on the revision specification that you pass it. So this is actually going to print out, big reveal. Okay. So this is actually the plumbing command that git log and git rebase and other commands that need a set of commits will use to determine those shars. So I actually created another alias called git pipelines, which will invoke a particular custom pipeline for a set of commits rather than just one. Now, those of you familiar with continuous integration and deployment, you might be wondering, why the heck do I want to invoke a pipeline for a series of commits? So let me give you a scenario where this might be useful. Imagine I'm a developer committing to Bitbucket, which is probably not too hard a scenario to imagine. And I've cloned master, and for the sake of argument, let's pretend we're committing straight to master instead of following proper branching practices. Now I've spent all day coding and I've created 5 new commits that I want to push up to the server. Now because we're committing straight to master, I'm going to go check whether master is currently passing the tests. And it appears to be, so I should be good to push. So I do a push. I'm just about to sign off for the day and go home and crack a beer when Bitbucket Pipeline sends me an email saying that I've broken the tests. Now here I've got a bit of a problem because I've created 5 new commits and I know that the latest one is broken, but the change that broke the tests could be in any one of those 5. Bitbucket Pipelines, like all CI systems, builds the latest push rather than going back and running each one individually. So what I'd really like to do is have some sort of efficient way of finding out which commit broke those tests. And it turns out Git actually has a command that will let me run a binary search over my repository to find which one broke it. Can anyone tell me what that command is? Bisect, yes, fantastic. So Git bisect lets you actually run a binary search between a range of commits to determine which one broke the tests. And the syntax for that is basically passing the SHA of a commit you know is broken and the SHA of a commit that you know is good. So basically the previous version of master and the new version of master that we've pushed. Now for bonus points, can anyone tell me the big O complexity of a binary search? Anyone want to take a stab? Well, okay, it's log n, which is pretty good. Binary search is an incredibly efficient way to find an element in a list, or find an element in an unsorted collection. So because it's log n, the expected time for me to find this regression is t times log n. Basically, the amount of time it takes me to run the tests times log n, the number of commits, so log 5. Now, that's fine, and that seems pretty efficient. But with Bitbucket pipelines, you can actually find it much more efficiently. With our pipelines alias, we can run the same pipeline for every single commit simultaneously, and we'll find our regression in T. So we're basically brute forcing our CI system in order to find out where this regression occurred. Now you might go, Tim, that's kind of cheating because yes, you're finding it in terms of T from the point perspective of the developer, but it's actually going to be Tn from the perspective of the CPUs actually running our build, because we're going to be running the tests for every single commit. And you're right, in terms of CPU time, it is horribly inefficient. But we pay our CPUs, I don't know, a couple of cents per hour or something, and we pay developers presumably significantly more than that. So in terms of efficiency, in terms of costs, and in terms of your time as a developer, brute forcing commits like this is actually a pretty effective way to go about it. And we can use those reflog short names that we were looking at before to say, hey, run this run this pipeline for every single commit between my previous version of Origin Master, so basically before we pushed, and the latest version of Origin Master that we know is broken. And this will give us our results extremely quickly. So I'm pretty proud of this alias. The only thing about writing aliases with a bit of complexity is that they can end up looking like this. Writing these scripts in line is pretty horrific. I've got some environment validation that makes sure I've got your Bitbucket credentials locally so you can actually hit Bitbucket pipelines. I've got some dependency checks to make sure that that JQ tool is installed locally so it can actually use it to parse some of the output from pipelines. And then I've got some horrific embedded JSON, which is the payload for Bitbucket Pipelines' API to trigger a build. And it's about when I'm trying to figure out whether I need 3 backslashes or 4 backslashes that I start really regretting submitting a talk on Git Aliases to the Atlassian Summit. But then I remembered that you don't actually have to write all of these aliases in line. It turns out that Git is clever enough that if you create a new text file somewhere on your disk, and then you fill it with a script, and it doesn't even have to be bash, it could be in JavaScript or Python or Ruby, and then you make that script executable and you put it on your path, then Git will invoke it as if it was just any other Git command or a Git alias. So instead of writing all of these aliases inline in your Git configuration, you can basically create an entirely new tool and invoke it that way. Now, to illustrate some of the power of this, I'm going to give you another example of a Git alias. Oh, actually a Git extension that's been created as a separate script. So this is a cropped screenshot from Bitbucket. Other than being cropped, it hasn't been tampered with in any way. And so this is a real sequence of Git commits from a real Git repository. Can anyone tell me what's a bit weird about these commits, other than the emojis in the right-hand corner? Anyone see anything a bit strange? Yep. The naming of the commits, the commit IDs? Yeah. Good eyes. So SHA-1 should be a uniformly distributed hash because it's used for security, and it is. Well, as far as we know it is anyway. So basically the SHA-1s that are assigned to commits are SHA-1 hashes of those commits' contents. Therefore, they should look pretty random when they're displayed in the Bitbucket UI. But here we have what looks like monotonically increasing commit numbers as they go up. So that's a very weird situation to be in. So the way I've created this repository is using another Git extension called Git Sham. Now what Sham does is it takes a single argument, a regular expression, and then it changes the commit message from your most recent commit by appending a random string of 3 emojis to it. And it does this over and over again until the commit SHA matches the regular expression that you gave it. This is terrible. You should not do this in any circumstances. I thought it would be kind of fun to celebrate release numbers by, if we release Bitbucket Server 4.14, then we can have 4.14 as the preceding SHA for the release tag. But the team weren't a huge fan of that idea. But what I can illustrate with this tool is that it's actually much nicer to write these tools as an extension script rather than an alias in your Git config, because you can write it in your IDE, you can use any scripting language you like, and you have syntax highlighting and all of that nice stuff. Plus, since brute forcing SHA-1 is incredibly CPU intensive, it's effectively a little small-scale Bitcoin mining operation just to change that SHA, we could write this in something much more efficient like C. As long as it's executable and sitting on your path and named git-something, then Git will invoke it as if it's a native Git command or alias. Now I want to show you a slightly more useful example of what you can do with a Git extension. I actually, a couple of weeks ago, built a new little tool for this talk called Git JIRA. Now what Git JIRA does is it lets you retrieve issue information from the JIRA API that is related to your current Git repository. So if I type in a JIRA issue key, then it'll pull some metadata about that issue and display it locally. And it'll also display if there are any branches that match that issue key. Now I tried to match existing Git patterns, so if you use -b, it'll actually create a new branch based on the summary of that issue. So it's gone and created a new branch called feature AUI 4394, and then taken the summary and plunked that in as a sanitized version. Now I'm also a big fan of JIRA's query language, or JQL. Does anyone here use JQL? Any people? Fantastic, okay. So it's like a SQL-like language for querying JIRA data. And I use it for all sorts of things, and I wanted to be able to do it from the command line as well. So if you use the JQL option, it'll actually print out any issues matching that JIRA query by hitting the JIRA API with that. And here we can come full circle because we've defined this as a Git extension. We can create a Git alias that invokes our Git extension. So that means we can sort of save useful JQL searches that we use regularly. So I can create a triage alias, which finds all of my critical issues in the triage state, and then just run git triage. So if you're a regular Git and JQL user, I recommend giving this a try. It's written as a Node tool, so you can install it using Node's package manager or Yarn if you prefer. And then you just need to configure it, and it'll cache your credentials and local JIRA server per repository. So if you're using multiple JIRA servers, you can connect it to different ones. So I mentioned at the beginning of the presentation that you can also share Git aliases with Git. Now, all of the Git aliases that I mentioned earlier in the presentation are available in this Bitbucket repository. There's a bit.ly link on the last slide, so don't worry too much about that. But once you've cloned it, you can add a new include entry in your Git config to include that in your Git properties. So this is kind of handy if you're sort of the Git magician on your immediate team and you're always helping out other developers with their Git problems, because you can create aliases that help them out and then ship changes to that Git repository and just get them to fetch them locally in order to update. One word of warning, this include property doesn't just include aliases, it includes anything from that Git config, so don't go including random Git config files that you would find on the internet. You can trust me though, I'm totally trustworthy. It just contains aliases, you can take a look. But in general, be a little bit careful about what you include. Now, we spent most of this presentation on the command line. Are there any source tree users here? Source tree, a few people? Oh, cool, fantastic, all right, maybe a quarter of the audience. So source tree doesn't support aliases directly, but it does have an analogous feature called custom actions. So custom actions, pretty similar to aliases. You define a name, and then you define a script that you want to run. And if you want to invoke the Git binary, just like Git aliases do by default, you can just pass in the path to Git, and then pass in the parameters that you'd like to define there. And this actually adds a new button to the source tree UI, or a new menu option rather. And you can also bind it to keyboard shortcuts. So if you're a source tree user and you'd prefer to set up the Stash aliases or Standup or any of those other tools, you can define them as custom actions instead of having to jump onto the command line. So thank you very much for coming along to my talk. I hope that I've shown you that Git aliases aren't just about shortening the commands you already use. They can actually be used to encapsulate some of Git's more complex and powerful options. And also let you chain commands with other tools from the Unix toolkit and anything else you have on your path. And that they are a really easy way to share your Git knowledge with the rest of your team and the broader public. If you want to check out any of the aliases that we looked at, you can check them out at bit.ly/gitaliases. I welcome contributions too if you have some improvements to them. Also, if you're a web developer, highly recommend checking out Ngrowth and JQ. They are indispensable tools for me. You can also check out Git-sham, although you shouldn't, it's terrible. And JIRA Git as well, I'd love to get your feedback on that. And if you're interested in random Git trivia and information about Git and Bitbucket and JIRA, you should follow me on Twitter @Cannonboy. Thank you very much for your time.